So the first part is obvious, we've already talked about it. If you're going to work with malware, you have to work in a safe environment, and what we're going to use is virtual machines. They're not perfect, but that's good enough and very convenient. Yeah?
Today, this is computer forensics, right?
No, this is malware analysis. Computer forensics is, I think, in a different room. Yeah, I think, yeah.
You're not hosting a...
No, it's actually, they had the wrong teacher. It's Richard Wu, and I think it's in Cloud 218. Yeah, good.
So you don't have a computer forensics?
No, they put the wrong teacher on it. I've got this class and he's got that class.
Oh, I know, but I signed up for Sam now.
Yeah, I know, that's wrong.
Oh, okay.
There's a bunch of things wrong in the schedule this time.
Okay.
Yeah. All right, good. It's a good question. Anyway, so we're going to run malware in the machine and infect it deliberately in order to see what it does. So the best thing would probably be to have real separate hardware, not connected to a network. But in practice, a virtual machine is good enough and it's far more convenient. So a real machine would be nice, but then you'd have to keep re-imaging it. And if it had no internet, you wouldn't be able to see the network connections of the malware. So virtual machines is typically what you do, and that will usually be safe enough, although there are sometimes VM escape exploits, so it can leak out of the virtual machine and infect the host. That's a possibility, but it's not, all the malware samples we're using are not going to do that. So VMware Workstation Player Fusion is what I like. Other people like VirtualBox. Some people even like Hyper-V or Parallels. They're all fine. They all do the same thing, Kimu, Zen. So one thing you could do is have your virtual machine only connect locally to host-only network if you don't want it getting to the internet. That's one option, although most of the time you just let it go to the internet. All right. And one thing you could do is you could take a snapshot before you infect the machine, so it's easier to restore it to a clean state. That's a good technique. And some malware detects that it's in a virtual machine and runs differently, so in that case you'd either have to change your virtual machine to be less detectable or modify the malware or run it in a real machine. But all the ones we're doing here will run in a virtual machine. They're not completely harmless. They won't infect or spread. They won't spread, but they will sort of mess up your one machine. So you really don't want to be running these samples on your host. You'll have irritating boxes popping up and stuff. So then we talk about, once you got a safe environment to work in, then you do dynamic analysis. Because static analysis, you can look at the strings and such, and that gives you some information, but it doesn't give you as much information as actually running the malware. And dynamic analysis is efficient and easy, and you'll find out exactly what it does, unless it is clever enough to hide its operation from you. Now, sandboxes are just automated processes that do this, and a lot of them online. Normal Sandbox, Joe Sandbox, Komodo, some are free, some cost money. If you go to VirusTotal, they will often show you the result of running it in sandboxes. A sandbox just automates this process. It spins up a virtual machine in the cloud, it runs the malware, it automatically records information like files accessed, processes launched, IP addresses connected to, registry keys made, and just records all that and automatically finds all this information. So it's pretty nice. It automatically does what we're going to do manually.
Can I say that
yeah.
Sandbox is a complex virtual machine or more complex?
That's all it is.
It's a virtual environment.
It's a virtual environment and a bunch of analysis tools. It's just all automated. So that's a lot of people like to do that. Yeah.
Would you allow me an additional question? But it relates to what we covered last class.
Yeah.
Because you said that, okay, in this class we are going to go over dynamic linking.
Right.
Not runtime linking. And I disregard the other one.
Not what?
I still cannot wrap my mind around the fact that dynamic linking is more convenient than runtime linking, even if you are loading the libraries from the real beginning of the process. And in my mind, I say, okay, we are loading these libraries and these functions that you may be using 10 minutes from now, 15 minutes from now, but
that's right.
They make noise, they create noise because they increase the number of processes.
Yes, so I mean, you could argue that dynamic linking is less efficient than runtime linking. Oh. Now, Microsoft Office 2010, which I used a lot, had runtime linking. You would install Office and use it, and it was all fine, but when you tried to click on advanced features, it would make you put the install disk in again, because then it would load a library that it didn't load by default, and so you always had to have that disk.
So this means that the runtime linking is a sort of reduced version of linking compared to the
Yeah, then it would only load when you actually use it.
Okay.
And that's a kind of strange situation, but almost nobody does that. In principle, that might be more efficient. In practice, people just use dynamic linking where it loads all the libraries when you first load the stuff.
Right, it allows
Yeah,
you to
but I mean, you could do it the other way. And Microsoft Office did, and it was not popular. People were very frustrated. You had to carry the CD with you because the installation didn't put all the stuff on the hard disk. You'd only do this if you really don't have enough room on the hard disk, but hard disks are big and cheap, so anyway.
Okay, but now it's
Yeah,
clear, okay,
yeah.
okay.
Anyway, that's good. All right, so you run your malware. You can run an exe directly. If you have a library and you don't have the exe that uses it, which is not common, then you can use this exe from Microsoft that will run a library. You can run, if this is what you might use to test a library without having to bother to write a function to use it, you can run one of the functions in the library with arguments to see if it works. So that's an option. I've never used it though. And so run rip.dil has install and uninstall, and so you could use run-dil to run the install function inside this library if you wanted to. Now, some functions we're going to see a little later, they don't have alphabetic names, they just have numbers for the functions, which is pretty user hostile, but you can do it that way. All right, you can also modify the portable executable header to turn the DIL into an exe. That's another way to test a DIL. All right, and then Process Monitor we're going to use. Process Monitor monitors the running processes in your machine, and it gives you all kinds of information, registry, file system activity, network activity, and so on. And what it really is, it's just a way to view the Windows event log. The Windows event log is always running, and it is extremely noisy. It makes hundreds of events for the simplest thing you do, so there are other programs like this that just try to make the event log easier to use by showing you more meaningful information. We're using any sandboxes. We're not going to use the commercial sandboxes. We're just going to do almost everything we're going to do in the virtual machine we already created. The virtual machine you downloaded or made yourself is what we're mostly going to use. Yeah. So if you run Process Monitor, it's reading all the events, and there are thousands of them per second. So if you leave it running for a long time, like 10 minutes, it will fill up the RAM and crash the machine. By the way, the same thing's true of Wireshark. If you run Wireshark sniffing, it will just accumulate all the network packets, and after a while, use up the RAM and crash. Both of them are not things you can run for a long time. You run them for a short period of time when an interesting thing happens, and then you make it stop sniffing. So if you launch calc.exe, it has 128,000 log entries. And that boiled into all these things. You see open key, close file, create file, query basic information, close file, create file. There's still hundreds of things going on when all you did was launch Notepad. It is amazing how many little events are going on to do the simplest task. Yeah.
When I play around with what is task, I think it's Task Manager from Windows, right?
Yeah.
Where you see all the buttons.
Task Manager shows the currently running ones. This shows you the whole history. You start it sniffing and it records everything until you stop it.
Right.
Yeah.
But the question I'm asking is, okay, you open Task Manager and you see, I think even when you're not using any software, there are at least 80 entries.
Yep.
Right.
Those are all things running in the background. Yep.
But then each entry has sub-entries.
That's right.
So this means that their entry is not a single process, it's an ensemble process, it's a
Well,
set of processes.
they're technically a process, but processes have threads and handles.
Ah,
So there are components, they call that from a single process, but there are components inside it.
the threads.
And each one of them connects to many libraries. It's quite complicated, and that's the main thing we're going to do in this course is get to understand how it works. Because to understand how malware works, you need to understand how Windows works. And so we will be digging into that. It's very, very right on target. So you have a toolbar here. You can start and stop capture. You can erase the old events. You can filter events, which is real important because Windows, when you're not doing anything, has thousands of events going by, and you don't care about those. You want to see the events that have to do with the malware. And you can choose what you want to see, registry information or just file information or so on. This is a way to thin out the large amount of data and make it easier to read. So the best technique, which is the one I recommend in the project, is where you first launch this product without running malware and then exclude everything. And then you watch anything that is new. That's the safest procedure, but it's a lot of work. And what I'm actually going to do is a much sloppier procedure where I just look for something with the name of the malware and exclude everything else. And that's an easier way to zero in on it, but if the malware was to launch a second program with a different name, I wouldn't see it. So it's a sloppier but faster technique. And that's something you'll get used to in this whole field. You try to use the easiest procedure. Even you understand that nothing is perfect, so you are open to the possibility that your research technique is not going to work and you'll have to try something else. But you always try the simplest things. You can filter with include by things like process name or operation or something, or you can exclude things and just see everything that's not excluded. You can do it either way. All right, and then there's Process Explorer, and everybody always gets these two products confused. Process Monitor is watching the log for a historical record of what happened. Process Explorer is showing what's happening right now. So when you close a program, it vanishes from Process Explorer, but it does not vanish from Process Monitor. The old log entries of what that process did will still be there. So Process Explorer just shows every running process, and we'll play with these in the project. You'll see how it goes. All right, so services are pink, processes are blue, new processes are green, new terminated processes turn red before they vanish, and it sort of helps. And really, they show up in the order in which they appear, so you can learn a lot here. You start the machine, the system starts, then it starts Windows, then it starts some services, then eventually it starts a login process, and then it starts Explorer, which draws the desktop. So this is the order in which things launched. And another thing to understand, all these SVC hosts, Microsoft Windows is running something like 100 services behind the scene, and they're all running libraries, and the executable is the same for all of them. And each of these is running like 6 or 8 services. So these are the hundreds of services running in the background, doing all the, providing all sorts of API calls to the programs that might run.
It is the same service run multiple times?
Yes, the executable is the same. You just have, then you have the name of the library and the name of the functions to run, like run dill 32. So it's the same SVC host, and each one of them is running like half a dozen background services. So you have something like 100 of them running, all before you log in. All these components of Windows are running, then you log in, then you run something like Firefox, and that is making API calls to all these background services that are running. That's how it works. So you can also view more information about a process in Process Explorer. And you can go to a lower pane, you can see dills or handles. And if you set it for dills, it will show you all the libraries. So here's Chrome, and Chrome is using all these libraries. Advanced API, Chrome.dill, cryptography, another cryptography one, graphical GDI one, there's the kernel one, and they're alphabetic. This is just up to the Ks. So a real program uses a lot of libraries, has a lot of functionality. All right. You can also go into the properties of a running process, and you can tell whether it is using these defenses. Data execution prevention puts permissions on memory regions so they cannot have executable code. And the typical rule is read or execute, write or execute. They will not let you write if you can write to an area because it's where something goes in like data from the user, then it cannot be executable. So there's no way for the user to inject code which then runs. And if it's executable, you're not allowed to write to it, so you cannot have self-modifying code. Your code has to be fixed, and the data that comes from the user has to not be executable. That's the standard policy, and that's enforced by data execution prevention that puts permissions on regions of memory. Address space layout randomization causes every process that launches is randomly moved to an available block of memory that's different every time to make it more difficult for attackers to, if they do manage to inject code, they have to find it to run it, and they don't know where they are, so it slows down attacks. There are simple solutions, though. You can write a JavaScript heap spray that just writes 1 million copies of your attack, so it fills all available memory, then you just jump at random, and you'll hit one of them. That's one solution to overcome data execution, address space layout randomization. But anyway, yeah, okay, what's the difference between this and Event Viewer? Event Viewer shows you the raw events. In principle, all the information is there. Process Monitor just takes certain events and displays them to you and hides all the other events. So if you open a file, there's like 100 events. Request to get permission to view the contents of a folder, execute the view the contents of a folder, get the properties of the folder, open the folder, get a directory, what's inside. There's tons and tons of little events. And Process Monitor will just have one line saying, open file, file name. That's why. It's just condensing the information from Event Viewer to make it easier for you to see. That's all it's doing. In principle, all the data is there in Event Viewer. In practice, it's too hard to find. All right, good. And so, by the way, you can check to see that the disk file signature matches the RAM image. Well, this will check the Windows signature. Most files are now signed, which means the developer has a cryptographic signature with the date saying, I signed it and this is intact. And if somebody's modified it later, the signature won't match. And this verify button checks that. However, there's a technique called process replacement, where when you run a program, it takes the file on the hard disk, the exe file, and it copies it into RAM, segment by segment, and then it runs from RAM. And you can then modify the contents of RAM so it continues to run, but it's not the same program anymore. That's called process replacement, and it's one technique malware uses. So that's a thing to know about. And so
This is also the normal functioning of the RAM, because the RAM, if you're working with different software, the RAM is not dealing with all the software, it's dealing with the software you're clicking now.
Well, yeah, but normally you shouldn't be changing, for example, the code of a running process. That's supposed to be non-writable. But you can change the permissions and write it, and then you suspend it, change the permissions, change it, and then unsuspend it. And now it continues to run, but it's not the same program. And this is what malware does. Especially if you find something with high privilege, like something that's running as an administrator, you can just change the code and let it do a different thing as administrator. That's process replacement. And so one way you can do is look at the strings. In process properties, in process Explorer, you can see the strings, just all the readable strings in the file, and you could look at the strings in the memory image or the hard disk image and compare them. So it's one way you might detect process replacement. Normally, they should be the same. The stuff in RAM should just be a copy of the stuff on the hard disk file. So you can open a document and see if it launches a process. For example, there are PDF exploits where you open a PDF and then it opens like a network connection and runs a malware process, and you might be able to see that in Process Explorer. All it should have done is open like a PDF viewer, but then it opens some other thing too, and you'd be able to see that. And we'll see that when we run a keylogger a little bit later. There's also a tool called RegShot, which people talk about. I've never actually used it because Process Monitor shows you all the registry changes. But you could also use this tool where you take a copy of the registry, then you infect it, then you take another copy of the registry and it shows you the difference. It's another way to do the same thing, essentially. All right. You can also fake a network. I used to do this, but I got tired of it. What most professionals say is just let it call out to the real command and control center. Let your machine be infected and be another bot for a while. That's so much easier. Just use the real internet. And I said, but then you're participating in a crime. And I said, yeah, you just don't worry about it. But what you can do is you can run a simulated internet outside your virtual machine, so it never phones home to the real bad guys. But it thinks it's phoning home and finds HTTP pages and DNS and FTP and all that, so you can see what kind of network connections it's trying to make. There's a program called INetSim in Kali that does this. You can also just use NCAT to listen on one port if it's trying to make network connections and so on. So you can do these things. Like I say, I don't bother with them anymore. I used to have it in the projects. I think I take the sloppy opinion of most professional antivirus researchers these days. Just let it call to the real internet. The easiest way to get it. And of course, you can sniff the packets with Wireshark, which you record the network traffic once it's connecting to a server, and then you can see what it's doing. And we'll have projects where you do this to see what kind of things it connects to. And you can view the TCP stream. You'll see it's trying to get something, and here's the response. So it went to get something from a server. Here it got a status 200, seeing it found it, and here's the file. And this is a binary file. It's a ping image. You can see the ping here. So it's that's what the network traffic will look like. All right. And so INetSim, you can run it out here. It simulates the internet, and then if you open a web page, you go to any web page, it'll show you a web page. It's the same web page all the time, but it appears to be the internet and so on. I mean, it's available if you want to do it. And if you run Nmap, it shows hundreds of open ports. Every possible service is available, FTP and TCP and SSH and everything, Telnet. It's just simulating every possible network service. So that
we are working with, this is the situation in which we work with multiple virtual machines, right?
Well, yeah, that would typically how you do it. Yeah. You'd have a Kali machine or a Linux machine simulating the internet, and then you have a Windows machine you're infecting. that connects to the calling machine and getting coding to the internet. So I mean, you can do it. It just didn't turn out to be as useful, so I took it out of the projects. Anyway, so here's Process Monitor is really valuable. Like I say, this is the one that watches every event. And Process Explorer is quite useful to have an immediate feedback of what it's doing. Redshot and iNet Sim I sort of got tired of using. Wireshark, though, there's no replacement for Wireshark. Wireshark is great if you want to see the network traffic. So that's what we're going to use in the project here. All right. Let's take a look at a Kahoot, and then we can get to the demonstrations, which is the main thing we're going to do today. Let's see if I can get to my right tab. 126, Chapter 3. All right. Looks like everybody's in. All right, so which method makes malware smaller? That's packing. We talked about it. You zip up the malware and you have an unpacker so the file is smaller on the hard drive. All right, so what kind of file do you run with rundill 32? Yeah, the name is logical. It runs dills. This is how you can execute a library without having to write an executable yourself. This is the all-purpose executable that can run a library function. All right, so which tool records thousands of events per second? So you have to somehow eliminate most of them to avoid going mad. That's Process Monitor that watches the event log with thousands of events per second and tries to exclude most of them to focus on the ones that are interesting. All right, which tool will show you Ethernet frames? Wireshark. All right, shows you the raw network traffic. All right, which tool lets you analyze botnets without connecting to real command and control center servers? that's INET SIM. Like I said, that will give you a fake internet so you can monitor the network traffic from malware. All right. So, let me stop this recording.